in this scenario, we have Marcos and Jill. And Marcos is holding a ball over their head. They throw the ball at an angle of 40 degrees, so I'm making my problem say 45. They have an initial speed of 10 meters per second, 8 meters per second. I'm making mine 10, but basically, same problem. And what we're looking for is how far away is Jill from Marcos. So we need to find the horizontal displacement. Personally, I like to do this the same way every time. I like to figure out how long it takes for the ball to drop to 0 vertical velocity, double that time, and multiply it by the horizontal velocity. So let's do that. First things first, we need to figure out our horizontal and vertical components. So we can actually, 45 degrees, we can sort of do it this way if we want to think of it as a triangle. Vy is going to be 10 sine 45, and Vx is going to be 10 cosine 45. And what we're going to find here is that they're actually going to be the same because it's directly a 45-degree angle, but that's not going to be the same for every problem. So just know that horizontal and vertical velocity are not always equal. So 10 sine 45, 10 cosine 45. And you can see that they are the same. I didn't actually have to put them both in. But so this initial velocity here is about 7.07 meters per second. This initial velocity is the same, 7.07 meters per second. So now let's find the time to the peak. And that's going to be the time it takes for the vertical velocity to drop to 0 with the acceleration due to gravity on Earth. We can assume that these are Earthlings and not Martians throwing the ball around, unless you're told otherwise. So let's put this at 0. This is 7.07 minus 9.8 t. And the solve is the same. Negative, so subtract 7.07 from both sides. Divide by 9.8. Oops. And we get 0.722 seconds is the time to the peak. Double that times 2, because symmetrical, parabolas are symmetrical. If we double that, we get 1.44 seconds is the time of the parabola of the arc. So now that we have the time of the arc, we can use that and find dx is voxt plus 1/2 ax t squared, but that's 0 because there's no horizontal velocity. So dx is just going to equal 7.07 times 1.44. And that's your horizontal range. 07, woohoo, 10.2 meters is how far away Jill needs to stand. It's pretty far.